Hello everyone. Now we are going to start with the compound microscope. As in case of simple microscope, we have seen the magnifying power was 1 plus d over f or d over f, and this magnifying power is very less. So if you want to see a really tiny object with the help of the microscope, you need larger magnification, and this can be achieved by using two convex lenses. So here in this case we are going to use two convex lenses. One convex lens which is nearer to the object, that is called objective lens, and one another lens we will use it later, we'll draw it later, and that would be towards the human eye, or toward the eye, that is called eyepiece. So the same technique I'm going to use here also. I'm going to draw this principal axis for the lenses, and this eyepiece will make the real image of the object, and we know that real image is formed when the object is lying between f and 2f. Real image, magnified image beyond 2f would be obtained. So here I'm going to draw one object. So this is very tiny object AB, and again for the convenience I am going to draw a ray which is passing through the optical center first. I want the magnified image. You see, I don't want that my ray diagram should go beyond this paper, so I can consider that my image should be formed here. So the second ray I can draw, which is parallel to principal axis, and it would pass through the focus, and I want this to meet here. So both of these rays, they are going to meet here. So here you will get the magnified image. Now when these rays, or this image we have got A dash B dash, now this image would act as an object for the eyepiece. So eyepiece of larger focal length I am going to draw here. So this is the eyepiece, I'm drawing it here. So both of these rays, they are going to fall on this image, and from here the lens is adjusted in such a way that this object, which is the image formed by the first objective lens, is lying between the focus and optical center of the eyepiece. Then let us consider the focus is here, this is the optical center. So in that case, this lens will give you the virtual magnified image of this object. This is basically the image formed by the objective, and now this is behaving as object for the eyepiece. So how we can draw? Best method is, again, I always prefer to draw it like, you can draw it like this. You can draw first ray which is passing through the optical center. Now virtual image we will get. So by choice you can draw it anywhere. Highly magnified image we are drawing. Now these rays, if you want this image, now these two rays will also diverge and you will extend them in the backward direction. Similarly, this another ray. So in this way, here we have got this image. So this is the magnified image A double dash B double dash. This is what? This is the objective lens, which is towards the object. This is eyepiece. This is towards the eye. This is the focus of objective. This can be considered as focus of the objective. And this is the focus of the eyepiece. Here, as we are using two lenses, so we must differentiate between the letters which we are using for the focus. So now you can see this is the final image, A double dash B double dash, and this you can see this is the inverted image. This was the object, actual object is this, and final image A double dash B double dash we are getting. Now you can see the magnification. It is highly magnified image. So this is a ray diagram of the compound microscope, and you see these two lenses, they are adjusted, especially eyepiece is adjusted in such a way that the final image is formed at the near point of the human eye. So this is formed at the least distance of distinct vision. So we can write this distance is from here till here. So this is the least distance of distinct vision. Now this is UO. This is VO. Means object distance for the objective lens, image distance for the objective lens, and this is UE, object distance for the eyepiece. Now we'll find out the magnifying power for this lens, this microscope. Now you see here two lenses we are using. Magnifying power of the total magnifying power of this compound microscope is the product of the magnifying power of the objective and magnifying power of the eyepiece. Now for the eyepiece, you see this eyepiece is behaving in the same manner as we have done for the simple microscope. Same way, you see this is the small object and it has made this virtual image, and same manner. So this eyepiece is behaving in the same manner as we have discussed the simple microscope. So I can simply write the magnifying power of this as 1 plus d over f. F is Fe here, the focal length of the eyepiece. But what is the magnifying power of this? This we can use the formula V over U. So magnifying power of the objective can be written as V naught over U naught, and magnifying power of the eyepiece we have already derived in the last lecture, this. Now V naught and U naught, little bit with approximations we are going to write here. V naught, you see V naught is what? Now you see this distance, as this object is lying very closer to the lens, so V naught is approximately this can be taken as the length, tube length of the microscope. So V naught, we are going to use this approximation here. V naught is approximately equal to length of the microscope tube. And U naught is what? U naught is, because this is very small lens of small focal length, U naught can be considered, it can be approximated to F naught, FO, focal length of the objective, because this point is lying very much closer to F naught. So one more approximation we are going to use here. U naught can be taken as F naught, but this is towards this side, so minus sign I'll use here. So let's substitute the values. So V naught is what? V naught is L over F naught with minus negative sign 1 plus D over Fe. So in this way you can write the magnifying power of the compound microscope. This minus sign is showing that the final image formed is inverted with respect to the actual object. So this was in the upward side, and here object, and this image is in the downward side. So that is why inverted image we are getting. So that is why this minus sign we can see in the magnifying power. So this is the total magnifying power for the simple microscope when the final image is formed at least distance of distinct vision. But second case is when the final image is formed at infinity, when the final image is formed at infinity. So the second case we have already discussed, and in that case the magnifying power was what? That we have already discussed in this way. So when you see the image or object is at the focus, image would be formed at the infinity, and in that case magnification is D over F. So that we have already discussed. So in this case also, if our final image is formed at infinity, if the final image is formed at infinity, we can write magnifying power is what? This would remain same because the objective is going to perform the same function. So that would remain L over F naught. But you see this magnifying power for infinity, when the final image is formed at infinity, will become this D over Fe. So this would be the magnifying power when the final image is formed at infinity. And there would be little change in the ray diagram also. So let me tell you what change would be there. Now you see final image would be at infinity, so these rays would become parallel if the final image is at infinity, and this is possible only when this object is exactly at the focus of the eyepiece. So when you will draw the ray diagram, you will make this object here at the focus of the eyepiece. If this object is at the focus of eyepiece, then all these rays would be parallel. So first you will draw this ray, and these rays you will make parallel to the first ray. For the convenience, in that case also we'll draw the ray which is passing through the optical center from here, and then these two rays you will draw in such a way that these two rays are parallel to this. So I am going to draw the ray diagram for the second case when the final image is formed at infinity. So when the final image is formed at infinity, so let's draw the ray diagram. This is what? This is the objective. Let us draw the principal axis. Objective is going to behave in the same manner. So this is the object. First I am going to draw this ray which is passing through the optical center, and then I will draw a ray which is parallel to the principal axis, and then here they are going to meet. So this object has to be at the focus of the eyepiece. So eyepiece we are going to draw here. Now this was AB, this is A dash, B dash, and so again I'll draw this ray, and you see this point is also the focus of the eyepiece. So let's draw first ray which is passing through the optical center, and extend them in the backward direction with the dotted line, and these rays And one more ray you can draw. Now all the rays we have drawn which are parallel to each other, so final image would be formed at infinity. And this is objective. This is eyepiece. This is focal length of the eyepiece, and this is the object distance also from the eyepiece. And this is your object from the objective u0, and this distance is from here to till here. This is v0, object or distance of the image from the objective lens. So this is the ray diagram for the compound microscope when the final image is formed at infinity. And magnifying we have already written, this would be minus L over F naught D over Fe. So this is all about the derivation and ray diagram of the compound microscope. Thank you.